Page 9, right? Here we go, page 9. So I'm going to go through the step. I don't know if I entered this already. A couple of things to remember. Listen carefully. I know it's Monday morning, and you're like, I need to wake up, Mr. Dixon. The negative only goes for the leading coefficient ever, right? So negative, I mean this button right here. If you go minus, that's anything that happens thereafter will have a minus, right? So if you put negative, you get a completely different graph. So real quick, the negative 200 back here, if I do negative, like the graph doesn't, like I just see, like I don't even see the graph, right, in this case. So it makes a big difference because really what's happening is it's 25x times negative 200. So you have like a negative 500x in this case, which is a completely different graph, right? So very important to get that right. We adjusted our window because originally, remember, Zoom 6 gets you to a standard window, and that just didn't work for us. How did I know? How could I foretell the y-intercept was negative 200 just by looking at it, right? So I knew that I had to like do something to my window. And I recorded it last lesson, I recorded it, right? So I'm going to go window, negative 10, 100. And then I went negative 400 to 200. That is the window that worked for us, right? So X-min, X-max, Y-min, Y-max. And there you have to use the negative buttons if it's a negative number. No minus. If you do minus, it will complain, okay? Hit graph. So we should all be seeing this, okay? Once you have your window, once you can see all intercepts, sometimes there are no x-intercepts, just remember that. But if there are, I would like to see them all. And the vertex is very important as well. So this is a pretty good window, and this is kind of what we expect to copy onto our graph, right? We're gonna try to aim for that. So we have that on our calculator, we keep that there. I'm gonna highlight, my key actually has this boxed in like that, because if you find intercepts, right, so x-intercepts, y-intercepts, and the vertex, you are good to go for graphing, okay, graphing purposes. And you may have seen this on my key already, but I will add that here. In general, included in a graph, right? You should have, so copy this down, you should have intercepts, you should have the vertex, you should have an appropriate scale, so that goes for x and y axis. It has to be consistent, right? If it's not consistent, I'm getting it ready for grade 12 provincial, they're going to take a whole mark off if your scale is off. So I'm going to show you how to do that. Labels. So by that I mean equation, and the axis needs to be labeled, right? So right now it's x and y, but soon, very soon, word problems are going to start creeping up. You're going to have time and money, right? You're going to have different variables attached to your x and y axis, right? We're going to have a context around this. And then last but not least, arrows, right? So make sure, in general, you put an arrowhead. Once we do word problems, that will probably change. So you need to be flexible. But in general, this is what I'm looking for when I graph. And I'm going to, see how it matters how advertisement is done these days, right? So you kind of need to do the same thing when you take notes, like make stuff pop out, right? When you review, you're like, oh yeah, what is this thing again, right? Oh yeah, it's highlighted, must be important. And now we're ready to graph. And I hope they won't cut us off, right? I don't know when they're going to call us down. They didn't specify, but I'm thinking pretty soon. So once you have that, I was nice enough to provide you a grid. And so I'm going to try to keep those things there. So there's your grid. So let's do the things we can do without much else, right? So we can call this X here, X-axis, Y-axis. Okay. Then I'm going to come up with a scale that works for me so that I can include everything. And you'll see that I tend to go by hundreds or thousands or 10,000s or something nice and round numbers, right? So let's look at when we look at our intercepts, 40 and 10, right, for the X values. So we should be able to have 10 and 40 in here. And so what I'm going to go for is, I'm just going to go 10, 20, 30, 40, 50. So if I'm consistently going up by the same amount. So that's 10, 20, 30, 40, 50. And I'm going to go to the negatives just a little bit, indicating that my scale here, like if you count the small boxes, right, it'll be every fifth box is worth 10, right? And that is consistent. So that's good enough. And then for my y-axis, I would look at the vertex for sure and the y-intercept. Okay, so I need to make sure negative 200 fits in here. So I think what works good is if you go minus 100 here and minus 200, this would be negative 300, right? And you might be thinking, wait a minute, going up by 10 here, and all of a sudden here it's going by hundreds, and that's fine. The axes can have different scales, but it has to be consistent within that axis, okay? So this would be 0, obviously, and then this is positive 100, positive 200, and I'm just going to go 300 here. I'm okay if you label every other one sometimes, that's fine, as long as I can tell that you're going up by the same amount. So this is now a scale that will work for us. So let's go plot the thing. So 40 and 10, so just make big dots like that. 10, 0, and 40, 0. And some of you are going to need to review your coordinates, right? Some students mix up X and Y values when it comes to coordinates. And you're going to have to make sure you remember which comes first. X first, right? Y second. And so we plotted these two. We're going to plot our vertex, which is 25, 1, 12.5. So 25 is going to be right in between 20 and 30. And then I'm just going to go up there. And this is 100. Halfway would be 150. So 112 is right about there. I'm not going to be too picky with that. If it's reasonable within reason, just plot it down and you're good to go. And then last but not least, our y-intercept right here. And there we have everything we need. Mr. Dirksen, do I need to label every coordinate here? No. If you show me the coordinates on the side, I don't require you to label it on here. Maybe last year you had to, right? The province doesn't require that as long as it's done correctly. So watch how I do this. I'm going to go start at the vertex, and I don't connect linear like this. I don't do that. I actually go off to the side a little bit, and then I curve, and again, and it should just keep going like that. And it takes some practice to do this, but it should not look like a V at the vertex. It should curve out a bit like that. And then we're going to replicate, do the same thing. It's a symmetric curve, remember. So we're going to go out. Oops, that doesn't look good. So that's why you have an eraser. Should have one. And maybe a light. All right, just go like this, out, through, and then down like that. That's good. That's your curve. One thing missing, your equation. That's all. Somewhere. that's a graph. That would be you get full marks for that. Okay. Arrowheads are there, labels are there. I have my vertex, I have all my intercepts. We're good to go. Right? So remember, first graph on your calculator. Once you have it set to where you can see the whole thing, find all the points you need, transfer it onto the paper. And it should look similar, right? Similar. Sometimes it's not exactly the same, but it should look similar to what you have on here. Okay, let's do one more. We're good? You're all so serious. Maybe I'm serious too. But relax a little bit. Just have fun with it. Have fun with it. Okay, let's enter this into our calculator. Is this, what form is this? Not general, right? We agree on not general. So why am I so specific on the not general? It's actually vertex form specifically. But what I mean by not general is that you can't say that this is your y-intercept. You cannot say that. It will be wrong. Okay, that's what I'm trying to. So I will just make sure this is a vertex form. And you know what? Overall, you're going to be fine not knowing the form, the name of it. As long as you know, it's like, okay, that's an equation. I'm going to type that into my calculator. So here we go. Y equals. Clear whatever is there. Mrs. Erickson, should I leave the y2 equals 0? I would, because you're going to have to find the x-intercepts. So let's just leave it. So we go exactly the way it's written. X minus 4. Don't forget to square, because then you'll have a linear equation, and you don't want that. Let's hit graph and see what happens. By the way, let's look at let's answer some of these forms here. So this is vertex form, and this is just to get you thinking, right? Opening without graphing, I should know that A is right there. Like the leading coefficient A is right in front of the bracket, so it's going to be pointing up because A is positive. What's the width? This would actually be a normal, we would consider it normal width because A is equal to 1. Okay, that's the explanation. So we already know a bunch of things. We actually know what the vertex is, folks. But if you don't see that, that's fine. But I will already tell you the vertex is, let's go back up. What happens to the -4 when we bring it out of the equation? Anybody remember? We change the sign. So it'll be actually 4. And -7 is not inside brackets, so it just stays the same. I can predict that that's going to happen. Let's see if it's actually true. Okay, let's see if it's true. So let's graph it. I'm going to hit graph. Ready? Is that a good graph, Mr. Erickson? Is that okay? It would be okay. But I think I can do better. I think I can box in around. There's too much dead space here. So I'm going to go zoom 6. Zoom 6 is your standard window. And look at that. It actually does a pretty good job already. My y-intercept is a little tight because sometimes if it's not showing, it won't tell you, like the calculator will complain. But I think I'm just going to leave it like that. Okay. So let's go and find the things. Y-intercept. How do you do that again? Second trace, get to the calculate. We're going to select value. And it's, for now, we're using x equals 0 all the time here. It won't always be the case. Okay. But let's say it's x equals 0. And there it is, 0, 9 is my answer. And you know what? I'm going to say that that's what I did to get it. It's not -7, see? It's not -7. That's what I'm trying to highlight. Let's find the vertex. Vertex, second trace, and it's either the min or the max. In this case, it's a min. The minimum because it's the lowest point, right? So we pick option 3. left boundary. So if this is the vertex where my pencil is, anywhere to the left of it, select that point. I'm just going to hit enter right there. Boom. And then I have to scroll sideways past it and select any point to the right of it. And when it says guess, just hit enter because it's asking you to start computing. And there it is. 4. Okay, that rounds to 4. 3.999, right? It will round to 4. And -7, which, hey, that's what you told us anyways, right? So there it is. It confirms what we already suspected. So yes, you can use your calculator, but you should also know, right? Maybe I will make a note.
Please excuse the interruption. This announcement is for all.
But other than to just show you on page 10 here. So right off the bat, I will find a video that goes from pages 9 to 11. Okay? 9 to 11. So those are these pages that have like the full-on grid. But this is the one. These 2 pages here have more questions for you to practice, and we're doing the exact same thing. It's just a bit more compact. It's not like you have 1 page per question. If you quickly want to flip to 29, I'm just going to show you here. Look at the grid. Is there a grid? Not really. So you know what the magic is to these things? You just ballpark. I'm okay with that. You don't have to use a ruler, but make ticks along the axes that are approximately spaced out equally, right? So sometimes I use my pinky because my thumb is too big. The whole page would be gone, right? So I just pinky, or something to help you go consistently. So I will post the answer key to that. I don't think I have a video for that one. But if you go back to page 10, make sure you have this down, right? Maybe I think I'm going to try to fit in one more graph, okay? Before we go, I know it's a bit late, but let's find the AOS is just x is equal to 4. It's a vertical line. Equation of min or max. This one is pointing up, so there's a min. So that'd be y is equal to -7. That's the y value of so the vertex gives you these 2 equations. X-intercepts, let's find them real quick. Normally you would go to y2, make y2 equal to 0. You have to hit graph, so that line is actually there. And then second trace, intersect. That's my way of doing it. I will show you another way later on. But then you just go closer to this one, hit enter 3 times. And you should already have this anyways. But you have 1.350. And second trace 5 one more time. You go there, enter, enter, enter. That's 6.65. Right? I use my calculator to do that. And I'm just going to go ahead and use that to graph. You know that the points are pretty small. So I'm actually just going to go 1, 2, 3, 4, 5. That's too small, but I'm going to go up by 2. 2, 4, 6, 8. And here, I'm going to go with the same. -2, -4, -6, -8. So I'm using the same scale for both axes, right? And I'm quickly going to put arrowheads on them. I'm going to call this y. I'm going to call that x, right? And 4, 7. So that's 4, -7 is right about there. That's you. And then 1.35. This would be 1. 1.35 is just over here. And then 6.65. That's you. 7. 6.65 is right there. And my y-intercept is 0.9. Oops, is that going to fit? Yeah, it is. Phew. Right, 8, and this would be 9 right about there for the y-intercept. So then you just go back to the vertex, out a little bit, and then just, I guess this is where you have the artsy side of you is going to come to life. Oops. And then just go over it again if it doesn't look quite right. Just go over it again and just make it look a little better. And then we have x minus 4 squared minus 7, right? Here's your graph. And that's how you do it, right? So what if I use a scale of 5? No problem. Your graph will probably be a bit more, it will look different because you used a different scale. Have a good day, guys. I'll see you tomorrow.